Previously, we covered auto-scaling, server architecture, and managing the deployment lifecycle. We've received a number of requests to continue this series, and today we'll be walking you through a real-world example of a cloud-enabled approach to deploying a major system upgrade using RightScale's Cloud Management Platform. By the way, recorded copies of all of these webinars are made available on our website in the News and Events section. Before we dive in, I'd like to cover a few housekeeping items. First, if anybody is having trouble hearing me, please text me now by using the chat feature in your GoToWebinar viewer. And note, for those who are connecting internationally, there are local dial-in numbers for most countries listed in your confirmation email and in the login screens. Second, we've reserved time during the webinar for addressing your questions. You can submit a question at any time by using the chat feature, and please feel free to ask whatever you like, whether it's technical or business-oriented. We make it a practice to answer all questions, and those that we can't fit in during the webinar will be answered afterward online. Finally, we'll be distributing copies of the slides and scheduling live demonstrations of the RightScale platform following the completion of the webinar. If you'd like a copy of the slides or to schedule a live demo, please email us at sales@rightscale.com. You can also try out for yourself much of the functionality shown today by signing up for a free developer account at rightscale.com. For those who are new to RightScale, welcome again. Please do check out our website, our wiki, and our blog in addition to this webinar to learn more about cloud computing and how you can use RightScale's fully automated platform to take advantage of the scalable, cost-effective, on-demand power of clouds across multiple providers while maintaining control and transparency. Okay, that said, let's get started. I'm joined today by Torsten von Eichen, co-founder and CTO of RightScale, and Ed Goldberg, evangelist, as well as core team members Matthew Small and Eugene Gimmelberg on the Q&A chat. At this point, I'd like to turn things over to Torsten, who'll start by giving an overview and then talking us through the steps we recommend for managing a major system changeover using a live demonstration. Torsten?
Hello everyone, this is Torsten. In the past webinars and other presentations at conferences, I talked a lot about design and deployment. So today is the second webinar in a series on managing running deployments. And we covered in the first one how to migrate to larger instances, demoed moving MySQL to a larger instance, and also how to do a new feature rollout, do an in-place upgrade of servers, of app servers, when updating the app code. Today we'll launch into dealing with failures, so we'll demo how we handle a failure of an app server and also how to do a major system update, and that's going to really be most of the time. So what we're going to do is launch right into the first demo, and then while servers are launching and things are happening, we can cycle back and explain exactly what's happening, but this allows us to bridge the time, the few minutes it takes for a server to actually launch. So we're starting with two front-end servers, a simple demo website, rightscaledemo.com. The two front-end servers have HAProxy load balancer and then Apache with PHP as the app server. And in the back, it hits our standard replicated MySQL master-slave setup. And we're having a problem with one of the servers. And for that, I'll switch it over to Ed. Ed, are you ready?
I'm ready. It's wonderful that I can actually organize a server failure exactly on time for you, Thorsten, but I have one ready for you. So if you switch the screen over to me right now, what I'll show you is at this moment, I've organized for app server 1 to fail. So if you look at my dashboard right now, you'll see where I have the mouse. There's an alert that's just popped up. Failed. Fill root file system. And if you notice in the plot for app server 1, disk free on root has just filled up. It's nice to be able to organize a failure whenever you want one. Okay, now let's dive into the deployment itself, and I'll switch screens to where my deployment is actually showing. And we can see that app server 1 is showing on our little block here a lot of activity. Something bad has happened. So my first reaction is going to be to go to app server 1. If I click here, it allows me to dive into that single server. Now I'm seeing exactly what's going on this server, and I'm just going to clone it right now and start solving the problem. By cloning the server, I'm making an exact copy of all the parameters that went with this server when it was launched. I'll change the name so I can remember which server's which. We had 2, we'll make him 3. And I'm going to give him a launch. So, in a few moments, what's going to happen is that bad server is going to be... Let me scroll to the bottom of this window and finish the launch. Okay? At this point, the launch is going on, and we're seeing this server take off. It's going to take the role of the other servers, okay? As you can see over here in the recent events, the launch has started. So without much more ado, let's go back to Thorsten's presentation, and while this server is starting up and taking over the IP address, he'll explain to you exactly what's going on at this point in time. So Thorsten, take it back for a moment, and when this server comes up, I'll tell you, and we'll complete the operation of seeing what it looks like with the new server in place.
Yep. So what's kind of important here is that Ed didn't actually look very much at what's happening on the server. It's really the reaction that is somewhat counterintuitive to smart system admins, right? As a smart system admin, you see, oh, root disk is filling up. Let me go in and figure out what's going on. Let me fix it. It'll just be a couple of minutes, and let me poke around. If you've ever been or if you ever watched such situations, what's typically happening is 10 minutes later, it's still 2 minutes away, and 5 minutes more, and it's still 2 minutes away, and so forth. and so that's really where the cloud is different, and where you have to get away from that habit. The first reaction ought to be, let me launch a replacement. There's plenty there, right? So go and use them. And the advantage it has is, in this case, the app server log file filled up. We want to be able to troubleshoot what filled it up, what caused it. So I don't want to go and just RM delete the file in order to free up the root file system disk space again, because then I can't troubleshoot. So in a way, what I want is have the server sit there with the root file system filled up, all of the evidence still intact, just launch a replacement, get everything back up and running and in a healthy state. And then later on, when I'm done with the emergency, I can go back and look at the log file and take my time to understand what filled it up, why this happened, how I can fix it, how I can remedy it, copy the log file to a different file system or to a different server if I want to rescue and actually, if I need the data off of it for click tracking or other purposes. So really what we've done here is, now coming back to the slides, one of the app servers failed, and we cloned the setup. So that doesn't clone the data on the server itself. What it clones is all of the definition of how to launch the server and how it is set up within RightScale, and we launched that. The way it is set up is that there are 2 A records, round-robin DNS hitting the 2 servers, and we're using elastic IPs, so things are set up so that the clone server will take over the elastic IP at boot. So as it comes up, it will go ahead and take over. So I'm just seeing here it is it has now launched in the sense that Amazon has provisioned a server which is now in the booting process and is installing the software and getting all of that running. So what we're going to do next is, once it's up and running, Ed will double check that it's working properly and that it is all there. And at that point, while the EIP already fails over, what's left to do is to cross-connect the load balancer. So both app servers run a load balancer, the HA proxy software, and it load balances really across the 2. The reason the cross-connect is there is this way. you can easily take one of the app servers down in order to do a little code upgrade, or if it's overloaded, the load balancing will adjust for that. So we have that as a standard part of all of the setups.
Yeah, we have a few questions coming in right about this exact process. One of them is, how does the new server take over the old IP address, and is there a good reason to use elastic IPs for the front end instead of just using a DNS made easy dynamic record?
Okay, so the way it takes over is it gets the elastic IP. So there's an Amazon EC2 feature where you can reassign an IP address. You can allocate think of it as a static IP address. You can assign it to a server, and you can reassign it to different servers over time. And what we set here, we used a feature in RightScale allows you to set it so that the elastic IP gets reassigned when the server boots. Since the old one is dead, there's really no point in leaving it there. We'll have a slightly different scenario with the second demo that we will be doing. The reason to use the elastic IPs over DNS made easy or any provider's dynamic DNS records is that the reassignment of the elastic IP takes a couple of minutes, but once it's done, it's done. There is no question about propagation or caching of DNS records, and also it means that the IP address for your websites and your service stays constant. So, for example, in our production RightScale deployment, we have DNS records defined for www1.rightscale.com, www2.rightscale.com, and most of us have SSH software set up with shortcuts that goes there, and it just becomes unwieldy at some point with the dynamic, or it's just more hassle with the dynamic DNS records. And for each server, there are more records. There's more than one record to update, and overall, it's just a cleaner solution to move the IP address. DNS was not really designed to have fast changing mappings. It works. We've used it for a long time, but now that there are EIPs available, I'd recommend using it.
Okay, and one question, at what point does the new machine take on the EIP? How do we ensure that the machine is up and fully installed before assigning the EIP?
So it happens as part of the boot process. Ed, maybe you can correct me. We do it as early as possible so that the machine and in fact, one of the very first things in the boot process that happens is the machine will wait for the elastic IP to have been assigned and have what we informally call settled. Or there's various routers or NAT devices within the Amazon infrastructure that need to switch over or get the new IP assignment, and they don't all switch at the same time. So we do some queries there in order to make sure that everything we can observe has switched, and only then continue in the boot process. The purpose being that we get a clean, known, stable IP address when the server is there and running.
Yeah, correct. Thorsten, are you hearing me just fine?
Yep.
Yeah. Let me just say that it's really important, and it's an added feature that RightScale did. Currently from AWS, associate EIP at boot is not a core feature. And yes, we do associate the EIP before we run any of your write scripts. So you can assume if you've associated EIP at launch that during your write scripts, you will own the EIP that you selected for this server launch, and that was in fact attached and verified that it was attached during the launch process.
So Ed, I see that the server, has it booted? Is it ready yet?
Yeah, almost ready. You can flip back to my screen if you'd like, and I can go a little bit more on the blow-by-blow of what's going on here.
I just wanted to also, the second part of the question, we'll show how not to launch it, do it at launch. In this case, again, the server we're replacing was dead or it's not usable. So there's no harm in having the other server take over as soon as it boots. But it's entirely possible to wait to first check that it's working properly and then only to flip over. And we'll show that in the second demo.
Yeah, we have the option of associate EIP at launch or associate sometime later. And there are impacts to this. Associating at launch, of course, is the cleanest launch, and that's what happens in an array grow and other automated situations for the highest reliability. But manually, you can move around EIPs. Remember, your software is going to have to understand that the IP address of this server just changed. That's pretty unusual, and your server better be very, very prepared for the idea of its IP address changing. So you get both options. But I give you a little warning here, changing the IP address of a server is something that frequently a program needs to understand what the IP address of the server is. So here we are, server number 3 is now launched, and it came up in a stranded state, which isn't uncommon, and that's why the knee-jerk reaction has to be start up a new server as soon as you can, because if you have a problem starting a new server, you want to be able to start another server very, very quickly. So whatever our problem was that still persisted, I'm going to go back and launch another server again to solve my problem. I'll just keep launching servers until I get a good one and see if we can resolve our problem. So our first server is stranded. So I'm going to clone the server again and launch another server. I think I understand why server number 3 didn't work, and I think I've fixed the problem. We'll make server number 4. Once again, my first reaction is launch another server. If I have a problem, I don't want to try to keep solving the problem by diving into broken servers. They're broken already. I want to launch another server to solve the problem. So here I am at the launch button. I'm going to launch server number 4. And server number 4 was a clone of A, so it'll take over the EIP once again. So here's a good example of a little bit of lore from cloud computing. Sometimes when you launch a server, it does fail. It can happen. Probably the most stressful moment for a server is when it's actually being launched. And it is possible when you launch a server for the first time for it just to fail. So I'll leave my number 3 at caution, and I'll launch number 4, once again associating at launch to EIP. And this time, the static association worked correctly, and I managed to steal away the EIP. So probably the problem with server 1 was bad enough that there was enough traffic going on that even AWS had a hard time reassociating my EIP. I just try again. Once again, roll forward, don't dig down. Yeah, Thorsten?
Now that you have 4 on the way, do you want to dig into the audit records for 3 to see what the demo gremlins prepared for us?
Oh yeah, let's dive in and look. But remember, I'm already starting the other server, so now I'm on free time. Right? So let's figure out what's going on. I'm obviously stranded. The evidence is going to be inside the server. We'll be able to figure out what's going on from the inside.
Look at the audit entry.
Oh, you want to look at the audits internally? Okay.
Audit entry.
While you're doing that, Ed, another question came in about the diagram and whether the load balancer and the app server are on a single instance, or whether those, so that they're 2 instances with both load balancer and app server, or 4 separate instances, and what the recommendation is in that regard.
Yeah, so if you, once the Ed switches back to the deployment screen, you'll see that there are 4 servers there. I guess now there are 6 there since he launched 2 more. Initially there were 4. 2 are the database and 2 are the front ends, which are both the load balancer and the app server. And that's primarily a cost issue. The load balancing really does not take much resources, so there isn't much load on the machine from the load balancing point of view. Now, moving the load balancer off to, or shutting down the app server part and launching additional app servers on the side is really not a performance issue until you have a large number of app servers. It can increase the reliability because on the front ends where you have the load balancer, you only have the load balancing software, which tends to change very little, if almost if ever. So it gives you more stable front ends, but you have to start out with 6 servers, which obviously increases the cost. So that's a cost trade-off more than a performance or other trade-off in my mind.
Let me sneak one more question in. With regard to this language we're using about cloning servers. I think people have some confusion about the notion of the actual server being cloned as opposed to the definition of a server being relaunched.
Very, very good point.
So there are questions around why, if a server has gone dead in the first instance because the file system filled up when you clone it, why isn't that one dead also, etc.
Yeah, so the cloning is really about the definition of the server. What you do in RightScale is you define a server by providing a server that is specifying a server template, which dictates what exactly gets installed, which software gets installed, and how it gets configured at boot time. And so cloning a server clones that definition. It does not clone the physical or the virtual machine itself. It does not clone the hard drive content or file systems. It only clones the definition. So when launching a server that is a clone of another one, we're really launching a completely fresh virtual machine that's initialized from the very beginning with the same software and the same software configuration as the other one. So it's giving you a new one that will look the same as the old one, but it doesn't have the data of the old one. So that's why in this case, where we have the filled root file system, the new one doesn't have that log file. It doesn't have the content of the file system. How are we doing, Ed?
Well, I think with my heart beating a little slower now, I've got a brand new machine. We can go back to our deployment and see how things are going. If you look over here on our recent events, that sort of tells us what's happening. 1 minute ago, my App Server 4 did in fact launch, went operational, and took over. So let's run through the timeline here. 10 minutes ago, about 9 minutes to launch, I had a panic. File system was filling. I needed to solve the problem. First reaction, launch server number 3 and get them warming up and ready to go to take over the problem. Server number 3, I had a problem. Turned out operator error. I had locked the deployment and couldn't steal the EIP to the new deployment. Initial reaction, the same thing. Launch server number 4 after unlocking server number 1 and launch again. So now, 10 minutes later, I'm live, the server's running, the customers are happy, and because it was only 1 out of the 2 servers, we never actually went down. We served half the performance for that moment in time, but the other server was taking over just fine, and I had no problem with performance. So my knee-jerk reaction is launch a new server, and if that doesn't work, launch a new server again. But I never get deterred into diving deep into why, because I know my servers launch, because all of the time, and we'll demonstrate this later, I'm launching servers and testing them from cold, and I know that my cold launch servers from the SVN deployment of the code, the EBS version of the database, work correctly when launched. And I verify that almost every day for major deployments. So here we are. I've solved the problem within 10 minutes, and I have now 2 servers sitting around, one of them with a filled up disk partition. I can go down into App Server 1 and see that now I can really spend some time not worrying about it anymore because the users are happy. And I can say my problem is a great deal of CPU load happened at that point in time. And you can see the graph is saying something went on, probably a denial of service that Ed Goldberg created for this demo. And number 2, the net result is it filled the file system. Note that I'm looking at a server that's dead. It's offline. It's not in use. And I can hand this over to developers or people to look at the problem, examine the logs. Maybe they're going to adjust the firewall and turn off that IP address for the denial of service, or whatever they need to do. But I'm out of the woods in 10 minutes. I have a new server, and I have all the evidence why the other server that is broken is still running and ready for me to look at. Let's go take a peek at the net result. With all this reaction, we didn't look at the real website. So here we are. This is what's servicing the customer. RightScaleDemo.com is on the internet and is available. And you can see here it's serving just nicely. I'll refresh the screen here. I can even go into some of the forums and play around with the demo itself. And it's working just fine. It's doing all the sort of things it should be doing.
Good.
So, back to you, Thorsten. I think we've solved the problem.
I will steal the screen back from you.
Okay, while he's stealing the screen back, I'll be preparing for the second demo. We're going to try to keep things very linear here. So, back to you, Thorsten. I'll get ready for not a failure, but a system upgrade.
Good. So the second demo for today is a major system update. And we'll start out with the same system, and I think Ed is going to use the two servers that are functioning in what he just demoed, and we'll completely replace them. So the goal is to add two completely fresh servers and bring them up with a new version of the code and new stuff. I don't exactly know what Ed all has changed. And we'll actually add them in two different ways. We'll add a server and we'll clone a server just like we did before. And I'll talk a little bit about some of the differences between the two, when to use one, when to use the other. The reason we're doing it this way is in many cases when you do a small update, you can do the in-place update of servers that we did last time. But when you do a major change where you're really reinstalling or changing underlying operating system, library, whatever app server or database things on the servers, and especially if you're making changes to the server template, to the scripts that are running, to things of that sort, it is much, much cleaner to launch fresh servers, so that you don't have an uninstall, reinstall type of scenario where things can go wrong and you're left without anything running. So by launching fresh servers, you have everything set up clean. You can test it before you switch over. When you do switch over, if something still goes wrong, you can easily switch back because the old servers are still there. So just from an experience point of view, when we do a release on the RightScale site, which happens about once a month, we do a complete relaunch because there's just too many things that are changing. We want to have the old servers still around. We want to have a clean install of the new ones. When a few days later, a week later, we do a little patch because there's some bugs we want to patch in the live system, that's essentially just a subversion checkout, source code control checkout. And at that point, we just do an in-place update of the servers. I'll come back to that, but I think Ed is ready with the demo.
Oh, always ready for you, Thorsten.
Let me pass you the screen.
Okay, while he's passing the screen over, let me say, normally I wouldn't launch these two servers in different ways. I just use the same way. But since you guys have been asking questions, one of the servers I'm going to clone and the other I'm going to add from scratch, just to show you how it works. Normally I would add both servers from scratch just to make it simpler. But let's do the same clone operation. We'll start with a server that was A, which is now server 4 today. And I'll clone him. So this is just the same as before. I'm cloning server 4 and making server 5, but we have a difference. This time, after I'm through cloning server number 5, I'm going to change the software being loaded by this server and turn off associate EIP at launch. Why am I doing this? I don't want the users to see what I'm doing. Okay? So here's server number 5, and it has the new software. So when it's through saving my name here, I'll go to server number 5 again. Let's add the word new on here so I remember that this has new software. Always good to keep your labels really nice and clean. Okay? Now I'm going to edit this server and make sure it does not take the EIP, deassociate it at launch, and put it to none. do both actions. None, do not associate EVIP at launch. It's important your servers you're using for development never touch your active EIPs. And I'll save that information. So that's one thing I need to do to this server. The second is I want different software. So I'm going to go into my inputs for this server only, and I'm going to edit the parameters. Click on the edit key. Now that I'm editing the parameters, I can adjust server 5 new, which won't be part of the public deployment because I've turned off the EIP, and I can change aspects of the code using deployment A. Okay? I really want to use B. Okay? What this is a brand new release of the software. Okay?
So what you
From
see
the
here is
SVN tree.
that normally we have, or Ed has the subversion checkout URL defined in the deployment, so it automatically applies to all servers in the deployment. And now he overrides it for one server so that he can change that and put it onto the new release. I guess at the end, you're going to have to remember to update the deployment so that future servers that you may launch get the new software. So it's a trade-off there here between changing it in the deployment from the beginning or changing it on individual servers and then coming back and fixing it in the deployment.
You're right, Thorsten, but I'm thinking ahead. Maybe that server that I had a problem with this morning is going to go down again. And if I want to relaunch that server, I want to make sure it launches with the A deployment. So I don't want to change it in my default in case an automatic action or maybe another person relaunches a server. He's going to get A. So I'm only changing it on this server so it's not possible for an automatic launch to cause a B server to come up. Got to think ahead. Okay, so it looks like we have 5 new ready to go. I verified very carefully I've got B. I'm going to click Launch and check all the parameters one more time. I scroll to the bottom, check to make sure in fact that I'm B-ish. Yep, there we are. I've got the B-type deployment here. Ready to launch? Launching. Okay, now remember this server will not interfere because it doesn't associate EIP at launch and it doesn't actually participate. So the only way we're going to be able to talk to the server when it starts up and gets running is by talking to it directly by its AWS IP address, not by the address provided from the EIP. Okay? Later on, we'll associate the EIP, and I'll show you how to do that. So that server's up and running. We should clone it again because I'll need 2. Once again, I'm thinking ahead. I'm going to need 2 in the future. It may not be good enough yet because when I debug the server, I might find it's not good enough, but I might as well launch number 6 and get him up and running. Okay? Now, by cloning him, I got all the previous parameters. Okay? So now I get the same thing. So that's one way I can do it. Okay? Let's go back here and see what's going on a deployment. And in fact, 5 new is pending. Okay? So now I have another server here. So while those are coming up and we're actually ready to let those take off, oops, I haven't launched him yet. Let's launch him. Always check to make sure I got what I wanted. Okay, I now have 2 servers ready for later that don't associate EIP at launch and they're waiting. See the nones here? Okay, while that's happening and I have a moment, I can show you how to add an EC2 server. So adding is just the same as cloning it, but there is a difference here. When I add an EC2 server, I'm creating a server from scratch. So it won't borrow the parameters or take the parameters from the previous servers. I've created a private copy of my server. I created a new version of my server, 5.1. I give it a new name. We're up to 7. Boy, you'll launch a lot of servers. Okay. SSH key, it's important I use the demo key. Security group is default. Availability is US 1E. Elastic IP, no, and don't associate it launch, add. So now I've created another new server. So that shows you both ways. I can either clone a server, taking the parameters from the previous one, or I can grab a new one for my new version and get the next version of the server. Okay? But remember, App Server 7 came out fresh from the deployment, so he's going to have the A deployment sitting out there. So we're going to have to edit him also. So in the case of launching one afresh, I may have a few more steps than a clone, which is why clone is so efficient. So Thorsten, while these two new servers are warming up, until they get to operational, why don't you explain a little bit more about what I'm doing? And we'll wait for these servers to come up, and then we'll dive into debugging an offline or off production server and seeing whether it's ready to migrate the databases and move over the EIPs later.
Absolutely. So I'm just taking the screen back here. So what you saw is, we're going through here and relaunching the servers, and what I wanted to say is sort of talk a little bit about the cloning versus adding a server. When you clone, as I explained before, you copy all the server-specific settings, etc. That's great when you replace a server as is, especially in the case of a failure. You really want to get a server just like the previous one, except it's a fresh one that is not failed. In the case where you're upgrading, it somewhat depends which one is more efficient. If all you need to do is repoint the source code control checkout branch, then cloning is the most efficient way to go. If there are changes in the server template, maybe new input variables that now come in, things that are somewhat more different, then adding might be a smarter way to go, so you get a clean slate. You don't get anything that has been overwritten in the previous server from previous upgrades or updates or various things. You sort of get a completely clean slate with just the definitions in the deployment and everything server specific that is undefined and that you can now fill in from scratch. I think we almost always clone in our own practice.
Yeah,
It's very rarely that we use add, but especially if you're changing from completely changing the server template, then because maybe you're moving to a different PHP app server or different Rails app server or whatever it is, then add can be a cleaner way to go. So a couple of questions coming in. Where's the Subversion source code control repository located, and do we support anything other than Subversion? This is basically with the Subversion checkout is from a URL, which means you can locate it anywhere that is accessible from EC2. We use an online service called whoosh.net where we keep our SCM. We do that because we have a distributed organization, and that's a convenient way to go. It can be your own, it can be anywhere. We currently don't have scripts for other SCMs. We do have scripts that instead will load the code from a tarball that is on Amazon S3 or on some other URL website that you can download. So there's a couple of other options, and you can always dive in and change it. So the Subversion script is actually just a few lines long. If you want to do a Git checkout or export, then you can do that as well. And that's actually one that's pretty high on our list because we're also moving our stuff to Git pretty soon. So that will appear, but you can always, that's part of the transparency and full control you get with RightScale, which is that you can override, you can inspect, you can see what we do for the Subversion checkout, you can go in and change it.
Yeah, that's really an important point, and I've done many custom situations where it's either a tarball or maybe a wget from some repository. Remember, these are example good best practice scripts you start with. You can always edit them, and if you don't want to use our SVN checkout or export operation, you could do any form of action that does pretty much the same idea, which is updating the doc root of the Apache server, and it would work just the same. But what I highly recommend is look at what we've done as best practice and good examples so you don't forget any steps like changing the ownership to Apache or gracefully restarting Apache after you've loaded the code. So it's really great to look at these examples up front and change them in the way you want. Whatever way you want to install the software, including embedding them in the right script itself if you'd like, all of that would work just fine. Right, so, Thorsten, you want to go in and take a peek at this new thing for number 5 and see what the new website looks like?
Absolutely. Let me just switch the screens over to you.
Great. Can you see my screen now?
Not yet.
I'm not getting the pop-up. Hold on. There it is. The show my screen got buried behind my screen.
There it goes.
Yep, got it.
Okay, very good. I wonder why it buried itself. Anyway, so as you can see, while you guys were yakking, my servers went operational, and I now have an operational server. Let me pop back up to the deployment screen so you see what it looks like from the very top. So this morning we had a problem, and we moved some servers around. And we have a lot of servers running and things are setting up. And my server number 5 and 6, our new servers, are available. And they're operational, and they're starting to get monitoring information come up. And all the other servers, I've just left them running. That's okay. Okay? Now, I'm going to dive into server number 5 new. That's a brand new server. Now, this server doesn't have an associated EIP. As you can see, it's none. So I'm playing offline. If I go to this URL, what's going to happen is I'm going to talk to this individual server, not through the load balancer, not through the RightScale demo deployment, not through the load balancers, but directly. So now I'm going to see exactly what the new server is going to look like. Wow, okay. This looks a lot better than that old server. And I can actually look at them side by side. Let me flip over to the old version. Notice the URL is the old server. So it's still running just fine. I always check, just being paranoid. And if I go over to my new server, which I'm addressing by the EC2 address only, I can see this is what my new users are going to see. And it looks to me like they're going to really like it. It's much better than the old server, and it seems to be operating just fine. But I was told by my people in the development area that I have some database migrations to do first. So I'm going to go over and check my second server to see that it's just as good as this server and make sure they're ready for the flip. Once again, I'm getting prepared with servers that are offline. Server 7 new. Nope, I should have been at server 6, shouldn't I? Thank you. Server 6 new. You guys can really tell this is a live demo, can't you? Let's see what this one looks like. Oh, very good. So 228 looks good, and 1.6 looks good. They're both looking great. Okay, so it looks like my new ready-to-deploy servers are just great. But this is a major server deployment. I'm not just moving over the look and feel of this website. I'm actually going to have to go into the database also. This is where it's going to get a little more tricky. And database migrations are always the trickier part of this. So let's get back to our deployment and look at our database master, because that's where my problem is. Before I can do this transfer, I need to go to this server and do some operations on my master. So I'll go into the SSH console for my MySQL database master and get prepared for the required migrations of the database itself. Okay? So here I am logged into the database server. For first-time people, just see what happened here. It knew the key. It knew the password. It knew how to get to the server. All I need to do is click on Launch a Console, type MySQL, show databases, if I can spell it right, and voila. I'm in here doing my database migration, and I'm ready to do what I need to do to get this server running properly. Okay? A lot easier than doing it online, a lot easier than fumbling with machines that are down. I have complete control. So the first thing I need to do now, because I am going to migrate the database, and this is a major change, is I need to tell my users we're in maintenance mode for a moment. Because I don't want to migrate this database with these users talking to the servers. So I'm now going to show you a second wonderful feature for this type of operation. I'm at the deployment level, and I'm running script. What that means is the scripts I run will run on all of the servers in this deployment. And I want all of my servers to turn on maintenance page. So place the maintenance page on the server in main mode. So I'm going to go to my servers, and I want to do it to every server. Why? I want to make sure that database is quiet. I don't want any transactions while I'm doing my database migration. Run the script. So this is the part that gets tight because my users are going to be informed the server's in maintenance mode, and I'm not making any money for a moment. Not a great situation, but this is a major upgrade. So I go to my my servers, and I verify, first of all, am I in maintenance mode? Very good. Let's go to the RightScale demo, the old one. Is it in maintenance mode? Yes. Go to the other server. Check to make sure it's in maintenance mode. Very good. All of the active servers are now not talking to the database. So I can go to my database, and I can do whatever action I need to do. In this case, I'm going to do a use B. And whatever action I need to do on the database. It doesn't really matter. For this real demo, I don't actually have a demonstration of migrating databases. I created an A and a B, and the servers are going to start using B. The point here is I'm in the database. There are no transactions going on. Okay? And when I'm all done with this database migration, I'm going to be able to turn the servers on in the new mode. So we'll quit out of our database now that we've done our migration or mock demonstration of a database migration. All right? Get rid of that window. Go back to my deployment and do the next action that has to happen. I know my servers are good, and they're all in maintenance mode, so everybody's going to see the same thing. Now I want to take my 2, 6, and 7 that are 5 and 6 that are running, and associate the EIPs. Note, I'm doing it while these servers are in maintenance mode. So what the users are going to see is the old A servers are in maintenance, the B servers are in maintenance, so they don't see any difference. It's just the same. I'll do the same with my second server. Associate EIP. Okay. And what we'll see is, let me get up here, I get a successful association. I'm going to wait a moment and make very, very sure new servers have taken over the load balancer and have taken over the EIPs. And while that's happening, the users are going to see the maintenance page. When it's very, very clear that these EIPs have moved down to these 2 servers, then I'm ready to turn off the maintenance page. And I've provided a script for that function. So I'm all ready to go as soon as they're ready to go. EIB migration takes at least 120 seconds for the users and maybe a little bit more. So we should wait, a minute or 2. So why don't we take a question for the audience?
Sure. Well, yeah.
Rather than taking a question, I maybe wanted also to walk through a little bit the steps that Ed is going through in real time there on the site. So this is let me go back here to the first situation was we had 4 servers, 2 front ends, the database in the back. He launched 2 additional app servers. They came up, and after that, he really set them up so that they're connected to each other and they talk to the database, and then run the database migrations. At the same time, he had the maintenance page up so that users didn't see and didn't hit the site. And then for testing, you saw him use the direct IP address or the direct host name of one of the servers so that he can test that works properly and is all there without disrupting anything else. And now we're at the state of reassigning the elastic IP so that traffic hits the new servers. And yes, they're still in maintenance mode, and we'll lift that when everything is done. So
well,
I just
good
wanted to
shape
go
whenever you're ready.
through the step-by-step here. This is pretty much the checklist we use ourselves and walk through. And with a major upgrade, we have many more servers than just the 4. There's really a number of people on a call walking through and handling different parts of the system, different types of servers. But it really goes through launching the replacement servers, giving them a quick test to make sure they launch properly. Then oftentimes we have database migrations that take a long time that we can run ahead of taking the sites down, such as adding new tables to the database, or oftentimes also adding new columns to existing tables. Those, if things are done right, can be done while the old system, the old version of the software is still running. It just ignores those. Then comes the critical moment. Everything is ready. We set up the maintenance page, so users now don't have service. We often at that point halt the old server processes or leave them running, depending on our level of comfort on whether that can cause something disruptive to occur or not. Run the changes to the database that need to happen while everything is down. That's the biggest critical chunk of time where the site is down. And if you're using a relational database, you're pretty much stuck at that point with having to take the site down. As soon as that is done, we fire up the new server processes and give them a smoke test, a little last-minute check that everything is connected properly and function fine. And somewhere in there, switch the EIPs over from the old to new servers. And there's a couple of different strategies here. And switch them earlier in order to cover up the time it takes for the EIPs to switch. Another one is to wait a little bit and do it later and be sort of on the safer side there. Once that's done, it's really in operation, and now we can go and test the site and watch the log files to make sure nothing unexpected is occurring. And when that has died down and is calmed down, there's often some post-upgrade database migrations that have to be run, such as cleaning up some of the data or doing other changes that require the new version of the schema but can be run a little bit later that don't cause major issues in the sort of the time from starting the server processes until these are run, such as they're setting defaults or filling in certain fields.
Okay,
And then
I'm
way
ready for you
later,
here.
a day later, 2 days later, we can terminate the old servers when it's convenient there. How are you doing, Ed?
I'm ready to
Switch
go.
back,
Let's
or?
turn this maintenance page off. I have users out here.
Sorry,
Oh, yeah.
make you presenter.
And Ed, while we're
Okay.
switching back to you, just wanted to give a heads up. We have about 6 minutes left before the top of the hour.
Okay, I'll clean up real fast, you'll see. No problem. So as you can see, during that period of time, the EIPs all migrated down to our 5 new and 6 new, and we now have everything running. I just wanted to show you something so you'll see this later. Remember we were looking at some pages before? I got network timeouts because what happened was when I associated the EIP, these old IP addresses are now stale. They're gone. So when you associate an EIP with a server, the IP address it had before while we were testing disappears and becomes unusable. So just be aware this will happen, and this is something you should expect. So I'll just delete these two tabs, obviously. I'm no longer talking to the servers, and they have their associated EIPs running just fine. Okay? Let me get back to the right screen. So everything looks just fine. Let's look at our server. We're definitely still in maintenance mode. Don't forget to turn the servers back on again. Okay, into scripts once again. The same as we did before. This time we're going to do our maintenance off script. I've written a little script that's particular to my servers. I wrote this one by hand. It's not a RightScale script, and it's particular to WordPress. So what this script does is it's taking off the .maintenance in the directory. In this case, the only servers I want to take off are these two, the 2 new servers. Now I'll know if I'm getting the right servers, because if I'm getting the right ones, maintenance will turn off. If I have the wrong servers, I'll still be getting maintenance, right? Okay, run those scripts. That happens very, very fast. So I'm launching a script that goes out to 2 of the active servers. I pick 2. I'm turning the maintenance off. Once the maintenance is off on those servers, my main site will no longer be in maintenance mode. Let's go over to the main site. I'll do a refresh screen. And lo and behold, RightScaleDemo.com comes out of maintenance mode clean into the new servers, and everything is launched correctly. It looks like the load balancers are right. Everything looks like they should look. Everything looks good. Yeah, I'm up everywhere. So it's time for some cleanup. Now, you might think at this point that with all these servers I have running, this is a lot of work. Lock down, which is my best practice, all of the active servers that are involved in this deployment. Quick recap, 5 new and 6 new are the active front ends. MySQL master and MySQL slave are the back ends. Everything else is trash. Start all is one button, stop all unlocked is the other. I'll click stop all unlocked at this point, confirm. This is a drastic action, so it's asking me to confirm, and it will terminate all of those old servers that are now no longer needed. So let's look at the little list up here, all terminated. So cleanup is very quick. So we launch lots of servers, we roll forward. When we're at a stable base and we have all our servers running, just clean up the mess and throw them all away. All those servers can be terminated. They're no longer part of the active deployment, and I've diagnosed everything and debugged everything. And we've done a full database migration within maintenance mode and started up a full new set of servers using new templates and a new database, B in this case instead of A. How's that for a major upgrade? Back to you, Thorsten.
Very nice, Ed. Thank you. I'm going to steal the screen back here and wrap up as we're running to the top of the hour. Getting the screen showing. Good. So what you've seen throughout here is really for me, principle number 1, which is always get the next server, get the next resource in the cloud. Very important. Roll forward. Get something fresh. Don't try to fail back. Don't try to fix in place unless you really absolutely have to. And we've done major upgrades with hundreds of servers running and changing out the database by launching a larger one and flipping over elastic IPs or dynamic DNS entries. And it's really phenomenal how you can do that in the cloud. Something that takes a lot of planning. If you do it in your own data center, you can decide within minutes and go and do it and have a high chance of succeeding at the first try and have the old servers around to fail back if something doesn't work. It's really difficult. Smart sysadmins like to immediately dive in and go and fix it. And I just have to slap their wrist and say, no, launch a new one. Go back later and find out what went on. So always do that and go and launch the next one. And really, right, in the cloud you have the resources on demand. You have, as you saw, Ed operated at a much higher level than SSHing into servers, typing things at the command line. It's more about cloning servers, about launching them, about running predefined scripts that he can add as many as he wants. He has a framework to add more that he likes to have in the way he operates the systems. He took what we defined as standard and he added a couple for the demo because that was more convenient. So it's the full control that throughout he can really see everything that's happening. I can watch it from my side as well. You can have multiple sysadmins acting at the same time and seeing the things and really operating at a higher level, full control, full transparency, everything that we provide in terms of predefined server templates or write scripts can be inspected, modified, changed, adapted, and customized to whatever you need, whatever Ed needed here in the demo.
Yeah, that's an important point, that you really have to feel free to start adding scripts, really hold back going to the command line and just typing things. As you see, I make typos and problems. When I spend a moment and I build a script, then I can do that same action correctly over and over again, and I can activate my operational script whenever I have to. So it's really important to take those actions you're going to do as an operations person and get them into a write script, add them to your operational scripts, and make sure they're ready for you to use in that panic moment when you're definitely going to mistype it or make a mistake. And turning on and off maintenance pages in the heat of the moment, it took me a moment to write a little script that creates a file and deletes a file. You can imagine it's a one-line script. But by having that script ready, when I needed to take the machine down in maintenance mode, 1 or 2 clicks, my machines are in maintenance mode. 1 or 2 clicks, my machines are out of maintenance mode. You can imagine what it would have been like if I had to go to all 7 of those servers, log in an SSH, create the file, go to the next server, go to the next server. If there had been 100 servers, it just wouldn't have been possible. So
Right.
just a moment. Use your scripts.
Yep. Well, Ed, thank you. That was really an interesting demo. The one script I didn't see was the one that puts my photo into the web page. I saw Torsten was on there. Is there a script that does that?
Well, it looks like we have a C migration, guys. You're going to have to come back to the next webinar to see Grandel's head.
Thanks very much. I hope it was instructive for everyone listening. We are going to stay online a little bit longer, but out of deference to those of you who have other obligations, please know that the recorded version of this will be going up on our site in the news and events section. So if you have colleagues or friends that you'd like to share it with, just point them there. We are going to stay online for a moment longer to ask a few questions, to answer a few questions. I'll ask them, you get to answer them, Torsten.
Feel free to ask, Grandel.
And then also a reminder, please feel free to visit the wealth of information we have from our free trial edition to our wiki, to our blog, and as well as contact sales at RightScale if you have particular questions or would like a customized personal demo. One question that came up that I will answer before we dive into some of the technical stuff was the question of what types of customer solutions are using RightScale today. Are they small, medium business, any enterprises? Just very quickly, we see the entire gamut ranging from startups and small businesses up through enterprise customers. At the enterprise level, yes, we do have large customers ranging from media to insurance to biopharma using RightScale. It is really a broad general purpose platform that covers everything from Web 2.0 style websites to grid application to test and dev and even to single server management. So we do cover all of that. Then there was another question, Torsten, I'll pass to you, which was, suppose that we as a customer are an ASP providing sub-clusters for different customers. Does RightScale allow us to organize instances by sub-cluster customer?
Absolutely, and that's one feature that we've had in from almost the very beginning is the ability to define what we call deployments and also to have different users that can access. So you can have an account, you can have multiple users that can log in and that can access the account, but that can access multiple accounts. You can also create what we call sub-accounts so that you can have sub-accounts for your customers so that they can actually even log into RightScale and do some management of their servers if they want to be able to do that, or at least look at what's there, and you can set the permissions so they can't actually change or launch servers themselves or terminate something. And so you can segregate the servers for the different customers of yours and manage that. We also provide some roll-up of the charges by instances so that you can see how much a particular deployment costs, because Amazon only gives you really the roll-up of the entire account at the end of the month. We can break it down into the sub-accounts or into the different deployments. So another question here is about the HA proxy front ends. Wasn't the site down in the first one? We had the failure in the first demo when one of the app servers wasn't responding. And the answer is that, yes, one of the IP addresses wasn't responding. What happens is that all of the browsers, web browsers, have a failover mechanism built in. So if you use round-robin DNS, which means that the DNS lookup returns multiple IP addresses, the browser will try the other IP address if the one it's currently trying does not respond. It's not a great failover. The different browsers behave slightly differently. So some users are going to click and not get anything for 20 seconds or so. So it's not the greatest form of failover, but it does work. And again, that comes back to the other question that was asked earlier: should we have separate front-end load balancer servers from the app servers? And if cost is not an issue, yes, that's a good way to go. This way, the probability of having to do anything to the first two servers that get hit that have the elastic IPs, the load balancing servers, probability there is very, very low, and that creates a somewhat more stable site. We haven't really seen that to be a big issue. Oftentimes, even in this case, the truth is that although the root file system was full and maybe PHP and Apache were less than happy and perhaps not serving pages, HA proxy, the load balancing software, really doesn't care. It's all in memory. So HA proxy was actually, well, I didn't verify it, but was working properly. So it was actually continuing to serve requests. So it's not a black and white situation. There's a lot of different options here.
Yeah, Thorsten, I had one more comment on something I actually discovered last night. When you have a failing server with an associated EIP, sometimes what you'll see is the user gets a very long pause because the server is responding but extremely slowly. This is very, very nasty. So what I did was I simply disassociated that EIP to get it to not be a black hole. So it's an interesting trick. If you have multiple IP addresses in a single record, so you have multiple A record failover like we're running right now, and one of those servers is not responding well, you might want to disassociate the EIP quickly so that the other server will take over faster and users won't get the bad pages from the one that's going down. And that improves the performance of the failover, not going to a server that's ailing. Now when you launch the new server, of course, it takes over just fine.
Quick last question here. What do you recommend as a best practice to upgrade the database schema? And that's really what we demoed, and I had the step-by-step list that we go through up there briefly. Let me flip back to it, where you see here in the middle, we basically prepare everything we can before making the changes to the database schema. We have the new servers with the new software up and running. They are configured properly. Everything is ready to go. And we make any changes to the database that we can do beforehand that don't interfere with the operation with the old code. We run them ahead of time. At that point, we set up the maintenance page and make the database changes. That's step 6 in here. And we work quite hard. Typically, we're looking at 1 to 2 hours sometimes of database changes when we come out of development, and then we need to work on moving some of those before, moving some of the changes after, and really optimizing and cutting the time down so that we're only down for a few minutes in the middle when we have to halt all of the app servers and make the critical changes to the database. So there's quite some work involved there, which is really DBA, database administrator work, in order to optimize that and cut it down. As soon as the database migrations have run, the new servers are ready and can be fired up, and then a quick test and off we go and open it up to users again. Of course, I guess it goes without saying here that all of these database changes are scripted. We're a Rails site, so we use the Rails migrations. If you use PHP, if you use other frameworks, they may have tools for that, or otherwise you can always write SQL scripts that make those changes, but you obviously don't want to be at the prompt typing SQL commands in to make those changes.
Yeah,
Sure.
Thorsten, you're right. It's so easy to make a mistake while you're doing that. I did want to interject one more thing, Thorsten. While I was in maintenance mode, I also have the option of actually swapping master databases to a new database. So I could have used that opportunity to roll my database from a small to a large database server during that period of time also. So while I'm down for maintenance, I could migrate a database. I could even swap out the database server to a larger or smaller server as necessary before I restart and take the maintenance off using my new configuration, a new database or even a new database server. Back to you, Thorsten.
Yeah, and actually that's a good point. Something we've done is stop the replication so that the slave does not get the database changes applied, so that if something goes wrong in those database changes, we have the slave that is frozen at the time just prior to making the changes, and we can basically roll back the database by promoting the slave to master, and revert back in a hurry if something awful went wrong. Good.
Yeah, great. Well, then we're going to wrap up now. Just a note that our two Q&A guys, Eugene and Matt, will stay on the Q&A lines for a while for any follow-on questions to get those answered for a few minutes after we conclude the webinar. There was one question from someone who said, how do I get notified of future webinars? We actually have plans to increase the frequency of webinars, and probably the best way is one of two ways: either sign up for a free trial RightScale account, you'll automatically get notified, or just send us an email at sales@RightScale and we'll make sure you're on the list. There's a lot going on. There were questions around our support for EC2 Europe and Rackspace's Moso Cloud, etc. What I can tell you for now is stay tuned in the near term. There's a lot going on at RightScale, and we will be announcing those developments as they come available fairly shortly. So once again, thanks very much for joining us today, and we'll see you next time.